Welcome to our class. Today we would like to talk about isometric sketches, how to draw figures on isometric. So steps on how to go. First of all, you need to sketch an isometric box, followed by sketching the views on each face, starting with the isometric lines that form the box. Then you have to add the non-isometric lines or other details for the object. Finally, you have to darken up the visible lines or object lines. So the first thing for our isometric drawing, we need to draw the horizontal line. Then our object should be inclined at an angle of 30 degrees from the horizontal. As you can see here, this is our horizontal line. So horizontal line. So having the object inclined at 30 degrees from both ends, as you can see, this first line and the second line here, they are all emerging from the horizontal or datum line for our object, and the vertical line indicating the height of the object. Yeah. So as I've said, the first step how to go for drawing the isometric drawing, you need to draw the horizontal line, followed by two lines. First of all, you draw inclining the object at 30 degrees from one side and the other one 30 degrees as well. Then you can project the lines to the size required or other details, dimensioning, step 2, and followed by step 3, where you can complete the length for the box. You can see now we are given for step 4, this is a complete box. And this box have some marks to indicate where the cutting or removal of unwanted part from our box are given. For our case, this part here, you can see measuring from the horizontal or from the bottom up to somewhere there regarding the size given. So the step 5, you can see the unwanted part has been removed, indicating that this is the object, how it's going to look like. And step 6, or the final stage, will be removing all the unwanted parts, remaining with the object that is of our interest. The first part was drawing an object being inclined at 30 degrees. That is isometric drawing. But for oblique projection, here, the object is kept at one side at a right angle to the horizontal. You can see here, the object is kept at a right angle so that you can see it very clearly. It is actual face. For the first case of isometric drawing, the object was kept at a right angle, at 30 degrees each side, for both sides. The essence was to see clearly the 3 views for the object. That was the advantage of having 3 views of the given object. You can see the 3 views at once. But here, you can see one view very clearly, or actual size, being kept at a right angle and the other one being inclined either 30 degrees, 45, or 60 degrees. But in this oblique projection, the projection can be done through two categories. In the first category or first approach, when you draw the object to full size, that is a Cavalier projection. It does not matter if it is kept at 30 or 45 or 60 degrees. What matters, you have drawn it fully and one view or one side. Mind you, in most cases, the front is kept at right angle or 90 degrees. But for the second category, which is cabinet, our object is presented or is drawn to half size of the object. Half size of the object or half scale of the object. Now for engineers or technicians, when they have ideas regarding production of anything in mind, then once they put it down on paper, they start by sketching, and it is a freehand sketch. You give what one is thinking of by drawing on a paper. Yes, not necessarily to be in dimensions. One can draw it just to represent the idea from thinking now is put on paper. So that is freehand sketch. You give it what is in thought to be on paper before matching for dimensioning and the other details. Now regarding the presentation of our objects in isometric, we need to differentiate or to understand the approaches of projections. One can use the first angle and the other one can prefer the third angle. And in most cases, these British prefer the first angle and these Americans prefer the third angle. That is according to locality of engineering. So in order to describe the orthographic views, we need to select a principal view, being first angle or third angle. Okay, for the first angle projection, here we have got a cone. This cone has been cut off, so remaining this piece of a cone. If the observer is to the left-hand side of the cone, viewing from this side, and what the observer have seen when it's drawn to the other side of the cone, for our case, you can see here, this cone has got the smaller diameter and the bigger diameter. The smaller diameter here and the bigger one somewhere there. So once this is the view, or the observer was looking from this side and the drawing was kept to the other side of the cone, this is termed as first angle projection. And for the third angle projection, it is done to the opposite. This same cone, and the observer was watching from the left-hand side of the cone, and the description of the cone has been done to the same side, or has been provided to the same side of the cone, which is contrary to the first angle. Let's see here. multi-view drawings of the object being at isometric drawing. If this is our object, this object have got 3 views: the top view, front view, and right view. The front view always is taken as the one that is have got a lot of details. How to select that this is a front view? The front view is the one that have got a lot of or many details that you would like one to note. So for our case, this view was taken, or was this view was regarded as front, because this one is bigger in our object in comparison to the right side. So for the third angle projection, the principle indicates that you have to draw, first of all, the top view of your object. As you can see here, the top view of our object, followed by the front view, started by the top view, front view, then finally drawing the right side. You have to remember, for the third view, where you stand for viewing the side is where you locate your view. As you can see, the right-hand side is where the observer was seeing or viewing the object, and on the same side is where the side view was kept. That is the case for third angle projection. Had it been for the case of first angle, this side, having seen or viewed from this right-hand side, but it would have been drawn to the left side of the front, and the top view would have been following the front view down there. It's the first angle projection. Let's see another one. For the isometric projection, you can see one is indicating that this is the top view of our object. From there, having a line in between the other one. So it's the top view, front view, then side view. Can you tell us which view now is for which category for our projection is? Is it first angle or third angle? Having seen that the observer was looking from this side, right-hand side of the front view, and the object, the view has been kept on the same side of viewing, that is our third angle projection. We have got another object here. Another object here, if the observer is viewing this object from this side and named this as front view, so the front view here, if it's drawn the front view and looking from this side, right-hand side of the object, then the side has been kept to the right-hand side. Mind you, the other indicator is where the top view has been drawn, on top or above the front view. Then you can conclude that this is for third angle projection. Now, how to go to drawing the if you are given the two sides, you are given the top from the object. You have a plan. You have got a front, and you need now to draw the third view, which is the side view. How to go? As you have said, you draw first from the object the front view, the plan or top view. Then now you are searching for the side view. So these lines can be projected from the plan. You can project, you have first of all to draw a line that is perpendicular, which is forming 45 degrees for the two views that you are given. You are given the front and the plan. So here you have to formulate the so here is where the line is coming from. Sorry for this. If it is indicating that is from this side, forming right angle, so you have projected all the lines from the plan. For example, our case, we have got the lines here, center here for the circle or isometric. For our case, this line here, you project them until when they meet this line, they have to form the right angle whenever they meet this. So also, you do the same for the front view. You project the lines, all the lines from this view. When they meet here, they have to indicate, or when they intersect here, they indicate a corner where they can form a certain cutoff of the material. So the projection for the three views can be done through these lines. One can use this method of making 45 degrees, and where they intersect, when they intersect this line for 45 degrees, you have to draw a vertical line being parallel to the ones that are forming this angle. Or another approach one can make is to have your compass, and you open up from this, making this is our center of the two objects. You can make a line here in between, here, then projecting, touching here, opening up the radius, then you drop somewhere there. Likewise, the same thing will happen for your object. Let me do this. Transferred. Centered picture. Okay. So for our orthographic projection on how to present the three views being given isometric, now you put them to orthographic projection in this manner. Freehand sketching or sketch a space provided the first angle projection of the component. For example, I've got this component for freehand sketch. We like to sketch this to the orthographic projection. You are given such kind of an object. So you have to select which side will be your front. For our case, this is the front, the bigger one, or which I can see it very clearly. I would draw first of all the horizontal line. Then I draw the vertical line. The vertical line. This is my object. I mean the box for. I'm drawing the box for the object. This is my front view. First angle projection. With the first angle projection, you need to draw, first of all, the front, followed by the plan, followed by the side, then the plan view of your object. How the arrangement for your views would be seen. So if this is my front view, very likely, I'm sorry for here. Mind you, the length for the front view, the same for the plan. But the other thing, that for plan is very, very important. How many lines do we have here? We have got this portion, first portion, second, and third. So we have got these sections here. Part A, part B, part C. As you can see, the parts here. And the third, for the front, we are supposed to indicate that there are portions that are cut off like this. Let me take out this first of all. No. Yeah. It was so big, so let's reduce it the size. The entire thing. I want another color. Get the another color here. Yes. And for the case of plan, one would see a line that is for the first part, A, second part, B, and the third part, C. Yeah. Part A, B, C. Here, A, B, and C. So this is being the front view. This is plan view. Then the side for the first angle. For the first angle, if you watch from this side, then you have to draw on the other side. For our case, we would have drawn it there. And how many lines do you have? Mind you, we have got the view here, A and B. And down there, so we have got this part 1, 2, 3. So you have to project the lines. So projecting the lines from this side can help you to get the part 1. Projecting this line here, you can get part 2, then followed by part 3. So how? This is for projection in the so-called first angle projection. First angle projection. First angle projection is where once you see from this side of your object, you have to keep your view on the other side. Okay, another one. This is for third angle projection. How to go? You need to project this. So what we have done for first case. So we regard this where we have got 100 units for the length be our front view. Front view. So first of all, you need to draw a full size. Then you have to cut it off, full size. Then we can see how the dimension here is 25. For our case, maybe 25 somewhere there. Another one from the top is given how much? 12. The top we are given 12 here. 12 here, 25. 25. So this looks like this. And there is this part that has been taken out. This part here. Yeah. This is for one part. A, B. This is for A and B. This part here is not there. So this line be taken away, this line here. You need to take out this line here. So our object here, Okay, let's continue with this object here. Outside the front view for our case would have been drawn to the size of this manner. Oh. Yeah. Indicating the total dimension upper part. Or for the front view, one would see this line here continues here. So we have got the object that is of 2 yeah. This one here, and it is seen somewhere there again, looking this way. But for the plan, if this is our front, for the plan, we'll have the same dimension for our object. The plan for our plan, then protruding or projecting the same lines from the top. Here is the line, top. This line from here to there, this one here. But in between, there is a line here, making the difference here. This is our line. So we have got part A here. This is part A and part B. So for the top, we have got 3 parts, 1, 2, and 3 parts. The bigger part, followed by this and the third one. So because we are dealing with the third angle projection, that means where we view our object, we have to keep the view on the same side. So for the total dimensions of the side, we have looked like this. However, there is a line in between. This line, if we project it to this side, this way, but here is a line. This part has been taken out. This part here. For our object, if we draw the outlines, look like this. It's an object for the third view, viewing from the left-hand side, and you keep it to the same side. This is the third angle projection. So this is the third angle projection for our drawing. Now let's see another thing that is very important on our sketches, that is how one can draw a curve to a given figure. It's very, very important for our sketches or drawings, where we need to know how we can place our curve. Given this figure, for example, we are given this figure. First of all, you need to construct the line, the horizontal line or the base. Regarding the dimensions, then you project the upward or the vertical line, is for our case. This way, construction line, mind you. And the other side as well, construction line. And horizontal line to make 37, as we are given 37 here. And here is 130. Here is 50 units for the length or diameter. But from this corner or this edge, we are instructed to have a radius for our curve, which is 35 degrees. So you have to open, making sure you have taken the dimension from the ruler by using a compass. You open up to 38. It should make a point within this horizontal line to mark that is our center. If you have really taken the radius 38 as we have instructed, so opening this, moving with this, ensuring that it starts somewhere there. So now you can draw the given arc. You can prolong. First of all, you need to construct a construction line. First of all, marking from this center, construction line, which is how much? Is 38 units. From the same center, we are given that from this point, how much it is given the units from this center as well. You have to regard this, moving, open up your compass up to the units given, moving in this horizontal line until when it is coinciding there, then you have to draw a required curve regarding the dimension that you are given. Now, the very important thing to note here is a line that is tangential to the two curves. Tangential. That means is forming is touching only once the arc and forming the right angle to the arc. But this arc, make sure that it has been prolonged in such a way it will give you a means of producing this a line which is touching once the arc, and also this arc, that line, same line will touch once, that is a tangent line to a curve or a circle. For our case is a curve, so we ensure that it touches once here and somewhere there. So drawing this straight line, this manner, that is our tangential line. So we have seen on how to draw a curve, given that a certain radius to our curve has been provided, and we have to make sure a tangential line joining the two curves touches once for each curve. Another thing very important in our drawings, draw this view showing clearly the method of establishing the centers of the arcs. So you can see, given that this is the drawing you are given now to redraw. So first of all, you need to draw the center line, our center line. Or construction line, you need to draw our center line somewhere there. Then taking your compass or divider to indicate, you mark your centers, given that from center to center is 50 units, center to center, followed by drawing smaller circles. This one here is how much? It's 12, and the other one is 9. So you draw the 9, you draw the 12 somewhere there, but in between there is a line that is for center. Here we are given this. And from this line to the other line down there is given that to be 18. We are given that this center, from this center to the outer one, see how much? It's 18 units. So from there, the other very important thing is the radius for our case. If the two circles differ, it won't make the figure to look like this. So the two figures, the inner what? Let's say let's restart here. Sorry for this. Positioning. If this is our center line, I'm sorry, having this. Sorry, this center line for this our object, as I've said, from center to center is given to be how much? Is 50. So our circle, first circle, second circle, that are formed to the radius of 9. And from the center line to the bottom line is given to be how much? Is 18 here, 18 units. 18. So also from there is another line that is 3 units from the bottom, 3 here. How to indicate this dimension? 3 in between. Arrow should be written very well here. 3 units. So the very important thing that we would like to present here is how to form the arcs. Arcs from the given centers. The outer arc for this part is given to be 12. That is our diameter. And the outer arc for this circle is the bigger circle, that means the outer one is 9. So we have got 2 radii. One is for 9, and the other one is for 6. 6 being our radii. These are symmetrical, they are identical. So one will draw a curve, construction line, mind you, construction line for a 9, construction line. But within this line, center line, we have got 2 radii, the one for 40 and the other one for 38. The outer one is 38 and the inner is 40. So you open up your compass, forming the radius of 40. That means the radius here, if it is 30, it will come somewhere there. Yeah. And the outer one, which is 30, so if you draw this one here, being 40, and the inner one being 38, draw in this way. So, mind you, this is a sketch just to show how the drawing will look like. So you first draw the center line, followed by this is 38, the outer one, the inner is 40. Yeah, that's how one can go to get the curves. This is a sketch on how to go for drawing the object that have got curves for our case. So this is how to go on drawing. Here you are given the curve that is showing the center. So this line here, radius 2, from the So from this center, you have got the inner radius, that is 4. The outer radius, that is 15, the bigger one. This can be somewhere there, up to somewhere here. You can see it started somewhere there, ending somewhere here. The radius for 15. And the inner one is 4 units. But the distance from this line to another one here is given. We have got the total of 22. But the radius here can give us the line how to project here, to prolong it somewhere there until when it reaches somewhere. Here is a parallel line. From this line, if we indicate the 2 units here, get the center here, then we can draw our arc to complete or to connect this line, this which is horizontal to the center line, and meeting the arc here, the bigger arc, so you can form this an arc here. Likewise, for this case here, if you have got a center here for radius 10, for the outer one, and the smaller one, mind you, is for 4, then you can accomplish the task for drawing the object required for our case. So this makes the end of our discussion on third angle and first angle projection, and how to draw the curves for different objects in our drawings. Thank you for watching.